Hi, here I am going to discuss Semester 3 Mathematics for Computing 2 2016 Paper 1 question number 1 to 5. Question number 1. We have three matrices A, B and C be any three square matrices of same order. Which of the following are true about them? Since these three are square of same order, we know that we can add, we can multiply, we can subtract these three matrices in any order. So, A, we can add these three together, right? So that is same as given 2A plus B then C. Since addition is associative, that means A plus B is same as one of these two. So part B, again we have the associativity under multiplication. So when we consider these three multiplications, so we have A, B and C. Same result will be there, but remember, you can't change the order of the multiplication, order of the matrices. The order is there. First we have A, B and C. First we have A, B and C. Here also we have associativity under multiplication. Here associativity under addition. C, we have to remove the brackets by using distributive property. Multiplication will be done from the left hand side of B and C by A. So, since we can't change the order, we will have always A in the left hand side. So, that is equals to AB plus AC. So, we have A as row, B as row and C as row. D, AB plus AC, that will be equals to AC plus AB. Since addition is commutative but not equals to CA plus BA as given here. Since multiplication is not commutative, that means AB not equals BA usually. So D is incorrect. E, as I told you before, addition will be commutative but not the multiplication. So ABC will be same as C plus B plus A. Commutativity and addition. So E is true. Answer is A, B, C and E. Question number 2. Here we have two matrices which are square of the same order 2 by 2 and we have to simplify A squared minus B squared. Definitely it will be an unique answer out of B, C, D and E. So let's simplify it. A squared minus B squared. A squared is the multiplication of A by itself, 1, 3, 2, 1, minus B squared also the multiplication by itself, 1, 4, 3, 2. So when we simplify these two multiplications, let's focus on the first one. So you know how to multiply two matrices. This will be with the same order. So first row with the first column and get the multiplication. So 1, 3 with 1, 2 column and get the multiplication between corresponding elements. So for this pair we have 1, for this pair we have 6, and finally you have to get the summation. Then we have 7 here. Similarly for the second element, that is relevant to the first row and the second column. First row and the second column. So you have to multiply first row again with the second column. Then we have 1, 3 with 3, 1. Multiplication between corresponding elements. For these two we have 3. For these two we have again 3. Summation becomes 6. Similarly, you can find the multiplications between the second row with the second column and again with the first column. Right? Second row with the first column and the second column to find the second row elements of the resulting matrix. In the same way you will get 4 and 7. Why? For the first element of the second row we have to multiply 2, 1 by 1, 2. Second row and the second column. Multiplication between corresponding elements. Here we have 2, here we have 2, summation is 4. Similarly, for the last element of the first matrix, then we have 2, 1 again with 3, 1. Then we have 6 and 1, summation becomes 7. Similarly, I think you can multiply b by b. Finally, what you get is, that is 1 plus 12, that is 13, and similarly here we have 12 and here we have 9 and 16. Then the subtraction between these two. Subtraction between same order matrices can be done by taking the difference between corresponding elements. So here we have 7 minus 13 and here we have 6 minus 12, here we have 4 minus 9 and finally 7 minus 16. So the final answer is minus 6, minus 6, minus 5 and minus 9. So this is C. And let's focus about the answer A. In A we have A minus B into A plus B. The same result we have for real numbers. So let's simplify this and check whether we can get the same result, A squared minus B squared. So when we simplify this, the choice in part A into A, we have A squared, and A into B, we have plus A in the left hand side, B in the right hand side. B into A, negative, B left hand side, A in the right hand side. B into B, again minus, B squared. We can have this thing as A squared minus B squared if we can cancel these two. Can we cancel these two? Actually, in generally, no. We can cancel these two when AB equals BA only, since we have opposite signs here. But we know that generally AB not equals BA. I mean, the multiplication is not commutative. So this is incorrect. So So final answer is only C. Question number 3. Again we have two matrices which are square and same order. So we can get the multiplication, subtraction and multiplication in any order of these two matrices. So here we have to simplify AB plus BA transpose. We know that if you have any two matrices with the same order, A plus B transpose is equals to A transpose plus B transpose. You can use that result and we have AB transpose plus BA transpose. Then again we know that for the multiplication AB and its transpose equals to B transpose into A transpose. We can apply the same result. Then for this one we have B transpose A transpose plus for this one we have A transpose into B transpose. So this answer is there in part D. So this is correct. This is also there in E. So this is also correct. And also we know that for any two matrices, A plus B is equals to B plus A. Addition is commutative. So you can rewrite this thing as A transpose B transpose plus B transpose A transpose. That is there in A. So the answer is A, D and E only. B and C. We can get these two results by substituting in these two this identity A transpose B transpose equals B transpose A transpose. But this is incorrect. In generally we know that the multiplication is not commutative. AB not equals BA. That is true for the transpose multiplication as well. So since this is incorrect, we will not be able to get these two results. Those two are incorrect. So finally the answer will be only A, D and E. Question number 4. We have a 2 by 2 matrix asking for the adjoint of its transpose. You know how to get the transpose. If you have a matrix capital A as A, B, C, D, its transpose is given by interchanging rows and columns. So first row will be the first column, second row will be the second column. So again, if you have a matrix capital A as A, B, C, D, you can take the adjoint for capital A easily. This method is only for 2 by 2. What you can do is, you can interchange the diagonal elements. Then we have D here and A here. And you can change the sign of the off diagonal elements. So we have minus B and minus C. So for here we have to find the adjoint of the transpose of the matrix. So we have to find the adjoint of the transpose is 1, 2 here, 3, 4 in the second column. Then we can find the adjoint. To find the adjoint, you can interchange the diagonal elements. and change the sign of the off diagonal elements, -3 and -2. So this is in C. So C will be the one of the correct answers. So what about A? If we can find the adjoint of the matrix capital A, that is, interchange the diagonal elements. We have 4 here and 1 here. Change the sign of the off diagonal entries. Then we have -2 here and -3. For part A, we have to consider the transpose of that again. So transpose of this matrix. That is equals to, first row will be the first column, second row will be the second column. Then we have this. So these two are same. So part A will be again an answer. So finally, the answer is A and C. Question number 5. We have an invertible matrix capital A. Invertible, that means A inverse exists. So we know that determinant A should be non-zero. Also, A can be known as a non-singular matrix. Since the determinant is non-zero and A inverse exists. We have a relationship between B, C and A. B is the adjoint of the matrix capital A. C is the cofactor matrix of capital A. So we have a relationship between these two. We know that adjoint is the transpose of the cofactor. So B is equals to C transpose. This is the choice B. So B is correct. All the other relations are based on the inverse of A. So let's find the relationship between inverse of A and BC. Inverse of A is given by this formula, 1 over determinant A into adjoint of A. You can replace the adjoint of A by B. So A inverse equals adjoint of A into 1 over determinant of A, that is equals to this. This is D. Then we have a relationship between the determinant of the inverse and the determinant of A. Let's focus on that. Suppose we have a 2 by 2 matrix capital A, B, C, D. Then we know that the determinant of A is AD minus BC. Let's take A as an invertible matrix. I mean the determinant is non-zero. So we can find the inverse of A, that is equals to 1 over determinant of A into the adjoint of A, that is dA minus B minus C. So determinant A belongs to all these 4 elements, D over determinant A minus B over determinant of A minus C over determinant of A and A over determinant of A. Then we can find the determinant of this. So we have to find the determinant of the inverse of A. Determinant of this gives when we multiply the diagonal elements, so D over A into A over determinant A minus the multiplication of these two. Sign will be positive, so we have B over determinant A into C over determinant of A. Then we have dA minus BC over modulus A squared. dA minus BC, that is same as AD minus BC. We can replace that thing by determinant A. So we have determinant A squared in the denominator. So we can build up the relation. These two will be cancelled. Then finally we have in generally A inverse equals determinant equals 1 over determinant of A. So that is also true. So the answer is A, B, and D. B, see my next video for question number 6 to 10.